Welcome to Session 3, Formula Fluency and Calculator Judgment. This lesson develops mathematical reasoning that stays reliable when a problem looks unfamiliar. You will learn to select a formula from structure, to enter grouped expressions accurately, and to preserve precision until the end. These are connected habits, not isolated tricks. Keep a pencil ready. We will build a mental model, use a repeatable method, solve a demanding example, diagnose an error, and finish with an independent checkpoint. Start with this principle. A calculator evaluates a model. It does not choose the model. Use this visual structure. Interpret is greater than right, is greater than estimate, is greater than enter, is greater than enter. Read every symbol and label before calculating. The first goal is to select a formula from structure. Connect it to the second goal. Enter grouped expressions accurately. Correct calculation begins with correct interpretation. When the surface details change, search for the same relationship underneath. Transfer means choosing the structure from evidence rather than waiting for a familiar-looking example. Step 1. Name every variable and unit. State the target and preserve its units or conditions. Step 2. Write the expression before keying it. Use a separate line so signs, factors, and labels remain visible. Step 3. Estimate a reasonable range. Keep the reasoning efficient, but never skip an operation that could hide an error. Step 4. Evaluate, label, and compare with the estimate. Verification is part of the solution because it tests the answer from another direction. Signal 1 is, the target is 2 minus dimensional. Respond by remembering. Expect square units. Name the response before calculating. Signal 2 is, a fraction bar spans several terms. In that case, use parentheses. The form tells you which tool fits. Signal 3 is, another calculation follows. Remember, store full precision. This separates plausible work from valid reasoning. If you cannot name the signal, pause and classify. A deliberate choice of method is usually faster than repairing a rushed setup. Here's the challenge. A rectangle has area 54 and width 6. Which operation finds its length? Restate what is requested before touching the choices. The first move is, name every variable and unit. Apply it directly to the quantities and conditions in this problem. Now use the core reasoning. Reverse A equals LW by dividing area by width. Keep each equality, comparison, or unit conversion visible. Pause for a midpoint audit. Check copied values, signs, units, restrictions, and whether the current result is the requested quantity or only an intermediate value. Continue by applying this control. Estimate a reasonable range. The explanation supports one option without relying on its position. The mathematical conclusion is 54 divided by 6. State it with any required units, interval notation, or restrictions. The final answer is 54 divided by 6. Compare it with the exact target and reject any choice that represents a common intermediate step. Verify from another direction. Confirm units and order of magnitude independently. The check should use evidence independent of the original calculation whenever possible. Try this checkpoint without copying the example. Which task cannot be delegated to the calculator? Decide which mathematical fact controls the answer. Pause and write one line of reasoning before committing. A visible decision is easier to inspect, explain, and correct than an unsupported guess. F. Focused hint. The learner must interpret the situation and select the relationship. Use the hint to repair the setup, then finish the reasoning yourself. The accepted answer is choosing the mathematical model. Explain why it works, and name the earliest line that would reveal a likely error. The central message is to select a formula from structure. Combine that with the discipline to enter grouped expressions accurately. Finish by remembering to preserve precision until the end. A result becomes dependable only when the method and verification are both clear. Reflection. What calculator error would an estimate expose immediately? Name the exact point where an incorrect path would first become visible. Practice one fresh problem for 8 to 12 focused minutes. Keep the work readable, verify independently, and carry the routine into the next session. Before moving on, close the notes and explain the method aloud from memory. Then invent one small variation, predict how the answer should change, and verify that prediction with a complete calculation.